Hello and welcome everyone. My name is Hanshal Mehta. I'm currently interning as a DevOps SRE intern at CloudRaft. And in today's session, we'll look into OpenTelemetry and something which is very core, which I like to do is eBPF. Everyone here aware about OpenTelemetry? How many of you are know OpenTelemetry, what it is, or something might just have heard about it? Great. We had a session yesterday by Bikram, sorry, I forgot your name. We had a session yesterday by Bikram. It was really nice session. It was an introduction to what I will be speaking here about. So let us just get started. So unlike others, this is going to be a different kind of a presentation or session. I don't usually like to read slides or just showcase what we have done. Rather, we will go with a new approach. We'll look this as a story. This story is somewhat similar to Bollywood. Unlike Bollywood movies, it has red chilies and spices, mirch masala. 50% is real, 50% is all mirch masala. So this story is about the case. This title is The Case of Lagging Launch. So this is a story about a startup which was based out of Bangalore. What did the startup do? It has a product. It's a very fabulous product named Momentum. So Momentum was a startup for content creators. It was a collaboration hub for content creators and users like us. It has a really used user base in India. So it is an observability tale with OpenTelemetry and eBPF integrated to it. It's a story of performance, power, and performance pressure and power of auto-instrumentation. So let us just first meet the stakeholders over here. So we have 4 stakeholders. For now, I am introducing you to 3. One is the surprise stakeholder. We have Deepa, who is the developer. She's the developer. She's a brilliant coder. She's the architect behind Momentum's application. She writes elegant and efficient codes. We have Ravi. Ravi is my favorite. He's the SRE. He's the calm in the storm. He's the guardian of Momentum stability and performance. He keeps systems reliable. Then we have the last product manager, which I hate. She's the voice of user and us. Voice of user and champions of Momentum visions. She always complains about why application is slow. Next on. Now this was the team behind Momentum's core ideology. Deepa, following the best practices, of course, modern days technology, modern days architecture, microservices. She deployed 10 microservices, which was a burden for Ravi. Ravi complained a lot about microservices because he wanted monolithic. But in short, we have to move forward with modern architectures and modern deployment strategies. So Ravi deployed it via Kubernetes, which is very easy for me. It's easy, right? Oh, sorry. So Ravi deployed this via Kubernetes, following the best practices. He deployed various other features too. He did the Kubernetes metrics for getting the metrics, the CPO status, usages, etc. And the PM always complained about that. So there was a pre-launch for Momentum where they just wanted to try their beta users how the app really feels, and that is where the pressure gets started. This was the Momentum's meeting room. Yes, this is the guy. This is Ravi. So day before Momentum's launch, they hired an testing engineer to test out their application. So testing engineers and beta users collaborated and found these issues. So pages were loading slowly. Second things was features were showing timeout errors, and errors appear randomly, unlike me. And everyone now feels the heat. Everyone thought, what was the pain points of all these characters? So Deepa was really frustrated. She couldn't find any logs or logs for the errors. And even if she wanted to find, she had to go deep dive into the traces. And sometimes she had to do manual instrumentation as well. Anyone who is DevOps SRE over here doing manual instrumentation? No one? Wow, everyone is smart. Then we have SRE, Ravi. So Ravi had high CPU alerts, but he couldn't really find where he could change the architecture or help to overcome these issues. And he didn't have any unified view across the entire infrastructure. Also, he didn't wanted to talk to anyone. PM, as usual, why the app is slow? But where is the app slow? What's going wrong? Everyone was complaining to the PM. Users gave a vague feedback about the application. So these were the pain points. The entire team discussed for 2 hours, and Ravi came up with the idea of manually instrumenting spans, traces, logs, metrics into the application. Now, Deepa was really scared. She saw the nightmare coming in. Why? Because she had wrote 10 microservices, 10 different languages, 10 different SDKs. She had to use 10 different SDKs of OpenTelemetry. She had maybe a backend application written in, like the API application written in Node.js. She had some background jobs written in Golang, and many more. So Deepa got really depressed. Why? It was a slow and manual process, which was, of course, error prone. She manually had to define the spans, use SDKs for every languages, which is hard again to relearn the entire SDK and implement the best practices. Then the consistent tagging is hard, and this would take from days to week. Everyone was feared because these all would take around 2 or 3 weeks. And the launch of the Momentum's application, the official launch, was planned a week later. So here comes our fourth stakeholder, which is the intern. Yeah, the intern. Meet Shivam. He's an over-enthusiastic intern. He likes to explore things. He was recently exploring eBPF, and everyone is like he always stays active in cloud native communities and such like that. And he asked this question: what if we could trace everything without even writing a single line of code? Everyone was panicked. How this intern can have such brains? Who hired him at first place? Is the HR mad? Then he suggested an idea: eBPF plus OpenTelemetry. Everyone didn't knew what eBPF is. eBPF will come back to eBPF later. So he told that eBPF and OpenTelemetry together can provide kernel level observability, real-time metrics traces, and no code changes. So how it actually works? So OpenTelemetry has another feature called auto-instrumentation. So what it does, there is 2 ways to deploy it. One is in the Kubernetes way, which Ravi will use, and another one is zero code instrumentation. For example, your architecture might not be deployed on Kubernetes. Everyone don't like Kubernetes like me, but you can also implement using standard EC2 VMs or EC2 machines. So how does it works? It deploys an OpenTelemetry agent along with the application, and it tracks the telemetry. What telemetry exactly? It uses low-level techniques. Again, low-level techniques like low-level hooks, trace points, trace context, baggages, dynamic proxies, and bytecode manipulation. I don't know what is bytecode manipulation. Thanks, AI. And now, what is eBPF? Anyone interested in eBPF? Oh, nice. Okay, thanks. So eBPF is actually a new way to write kernel codes, custom kernel codes, and deploy it to kernel without modifying the existing kernel. So it was originally developed for network packetting, mainly because of TCs or classifiers. You can call it as IP tables for firewall security stuff, but it expanded to security, observability, and networking solutions. Developers always write small sandbox programs. We have many cloud native projects based on eBPF. Cilium is leading, I guess. Then they implemented all these stuff, and these were Deepa's views. Before, everything was working on guesswork. Second, she was deep diving into logs. And third, it was, of course, a huge time waste for the company. After she saw end-to-end traces immediately, she also pinpointed that the collaboration service had a huge was depreciating day by day and had some bugs, and the bug was found to be n+1 query issue, which was fixed in hours and not in days now. And this was done without no codes required. Then we have our SRE view. SRE had CPU alerts, but didn't have any context or clarity to do that. Later on, he got golden signals, which were captured. Golden signals were captured. Golden signals are basically those signals which are more important, which occurs repeatedly. These are the golden signals which were captured and immediately fixed. He traced the high CPU request from which microservice it was originating from, and now he could correlate the application infrastructure with the app data. Also, mean time taken to reduce it reduce MTTR. Anyone who knows what's MTTR? Okay, so, sorry. Yeah, mean time to repair, exactly. So MTTR is mean time to repair, which basically means how much time we require to solve a particular issue. It was reduced dramatically, and now he can sleep peacefully. Now, what is Priya's views? I don't care about her, but okay. Before, she had a vague user feedback, can't debug the origination of the issue, and later she can see where users drop off. Bounce rate tied to slow DB query, which DB is working, which DB isn't performing well. Measured real impact real impact of fix, and data-driven product decisions. She used to make decisions which was a burden for developers and SREs. Now, later on, after this, they had a smooth launch. Bottlenecks was fixed, confidence was restored, momentum launched successfully. Minor issues solved in minutes, not in hours or days. The telemetry turned chaos into control. But how did it do that? So let us just get into technical part of it. So this is what the instrumentation code looks like. So this instrumentation code is nothing but a custom resource by OpenTelemetry itself, where you mention all the configuration required to instrument your application. For example, she deployed a Node.js application which is used to serve HTTP applications. So she mentioned over here that instrumentation will be done for Node.js, and what are the configurations required. The log level, you might use debug to get more information about the logs. The traces, OTLP. Anyone familiar with OTLP? No one. OTLP is basically similar to HTTP, but it is used by OpenTelemetry. It's like an OpenTelemetry protocol. Like HTTP, we send and receive data with a particular context. For example, header, body. I'm not sure what else. Header and body are pretty common over here. Authorization. OTLP is something similar, where you define the way how you will transfer data. Then there are metrics, logs, exporter, and everything there. And here are the propagators. Propagators are basically those contexts or those techniques which you want to retrieve your data from. So for example, trace context is really useful for acquiring traces in a particular application. It instruments the code to the Linux system logs, where it assigns the eBPF application to trace point contexts. We have similar baggage, and we have these samplers. We can also modify these samplers as well. Now, how the collector configuration, deployment configuration looks, because of course we have deployed the instrumentation part, but how instrumentation knows it belongs to which services, or how does it do the service discovery part. So collector is pretty straightforward, nothing much. It has processors, spec, exporters, services. This was explained really in detail by Bikram yesterday. Second thing is how deployment. So how instrumentation knows which application is running and whom to instrument the traces and the logs. This is where annotations comes into place. Annotations are basically something similar to labels, but they are used more than that. Annotations, you provide an annotation for which application you want to instrument yourself, instrument it. Like for example, we have inject Node.js as true because we are injecting it into a Node.js application and also providing the container name. It is to be present in both the metadata config as well as the container config. Now, things seems pretty simple over here, but what it can actually do, what it enables, it has zero code implementation. It works across polyglot microservices. You might have hell of microservices. Your developer might follow modern architectures, everything like that. Your debugging rate would, increase. Then you might have deeper insights to these systems via eBPF. Since it's a low-level kernel technology, we can have really good insights of what's going on. Then we have instance logs, traces, and metrics without applying any code changes. But what it can't do alone. So it is very limited to customization. For example, while writing via SDKs, you might write custom spans to a particular services or particular routes. You can't do it over here because it is already taken care by the eBPF application, eBPF program itself. Then the full business context, of course, might not be recovered here, since it lies in the layer 2 and the layer 3 of the OSI model. You can't really get the full business context. Then eBPF supports varies from environment to environment. Since it relies on kernel changes from every distribution. For every distribution, for example, kernel version for my Ubuntu machine would be 6.3, and the eBPF would support only applications till 5.3. That's where eBPF starts to hesitate. You still need domain knowledge to interpret the data. So eBPF is not really useful when you don't have the entire knowledge of your application data. You just need the system logs as well as the network packets which entered through a particular port. Use it with care, not blindly. Then we got appreciation too. So this was the appreciation by President Donald Trump. So
there's an Indian startup named Momentum, which doing pretty great things. Now I announced 35% tariffs to India.
Sorry. Okay, it was a wrong video. Now we have Modi ji too, also promoting Indian startups.
नमस्कार मित्रों.
Okay.
ये जो मोमेंटम नामक स्टार्टअप है वह हमारे कंटेंट क्रिएटर्स का काम बहुत आसान कर रहा है. मोदी है तो मुमकिन है. धन्यवाद.
And these appreciation took momentum to another level. They were famous. As you know, President Donald Trump also recognized them. It went, the application scaled at a huge, had a huge impact all over the world. Of course, US did the same thing, tariff laga diya. Momentum won't be supported in US now. But it serves India, which is indirectly works on a very large scale. They have a very large user base now, and things again start to go in the wrong direction. But why?
There's an Indian startup named Momentum.
Okay. Yeah. So this was a post-launch stress. This is Ravi. After the huge success, after so much appreciation by every other political parties as well as celebrities, I'm sorry, it's not free to generate AI video content. Seems Ravi is not happy because logs are massive and errors are very cryptic. He couldn't find any errors. He couldn't correlate any errors over here. And Ravi was going to a logging nightmare where duplicate errors were found, logs were inconsistent, and searching logs were similar to knowing a lot of regex. Regex is not simple, but why to implement it manually when everything is open source, and you can implement open source techniques to find the best out of your data. And also there were slow running queries. So Ravi remembered, like in 2024 he attended a conference or an event in Bengaluru, which was the OpenSearchCon. What did he learn? OpenSearchCon, OpenSearch is really good at storing vector data, as well as storing logs. What were his takeaways? OpenSearchCon, like at OpenSearchCon, Ravi learns how modern observability can solve the log chaos. After implementing all the practices which he learned from OpenSearchCon talks, he implemented the centralized and structuring of logs, ingest via OpenTelemetry and collector, and also the search filter with visualizing with OpenSearch dashboard. How it helped them? Deepa can now trace IDs and can jump from trace to related logs. Also, she can filter by environments. By services. Ravi can now build dashboards. He can trace errors. Also detects log spikes before alerts and even triggers them. Priya, why is she here? Okay, can correlate logs with user behavior. Understand which errors users actually notice. So this was something similar what Momentum adopted. They have multiple services and an OpenTelemetry collector running over there. And the data prepper is used for enriching the data coming from OpenTelemetry, and it was served to OpenSearch dashboards. So I'll just simply talk about what is log analytics. We are running late on time. We are running short of time, sorry. So it's a process of collecting and processing logs and gaining insights to what log data you have. So various unstructured logs are coming from OpenTelemetry towards the data prepper, where data prepper enriches them and further sends it to OpenSearch dashboards, which are in structured format like JSON. And this was the same architecture adopted by Momentum. So moral of the story: without telemetry, you are guessing. With auto-instrumentation, you're observing. Developers debug faster. SRE maintains reliability, and product managers see the real impact. For more information, I've written a blog, as well as there is a GitHub account, GitHub information, where you can find all the implementation which I have done. And thank you so much for attending this session. This is me. This is a small feedback form. If you like the presentation or the talk, or anything you don't like it, please share a feedback.
Yeah, thanks, Hanshal.
Yeah.
We're short of time, so we can take any questions after. Thank you.